In this tutorial, we're going to have a look at Pythagoras' theorem. The theorem states a relationship between the three lengths of the sides of a right-angled triangle, so that if you know the length of two sides, you can work out the third. The theorem's equation is a squared plus b squared equals c squared. So what do these letters mean? Well, they relate to particular sides in the right-angled triangle. So C is always the hypotenuse. The hypotenuse is the side opposite the right angle being 90 degrees. The hypotenuse is also the longest side in a triangle. And A and B are either of the other two sides. It doesn't matter which way round, as long as it's consistent throughout your working. So let's have a look at a few examples and we can see what's happening here and how to work through the equation. So if we work out here, we want to find the length of the missing side. So first of all, if we label the sides, so the hypotenuse is always C, and A and B, we can label the other two sides. So we write out the equation, A squared plus B squared equals C squared. So let's fill in what we know about the triangle. Well, we know A is 4, so we've got 4 squared plus B, which is 5 squared, which equals C squared. So now if we work out what these values are squared, 4 squared is 16, 5 squared is 25, equals C squared. 16 plus 25 is 41, so 41 equals C squared. Now we want to get rid of this squared, and we can do that by finding the square root of C squared, and that will eliminate the squared. But remember, whatever you do to one side of an equation, you must do to the other side of the equal sign. So if we find the square root of one side, we must do the same to the other. So here we get the square root of 41 is equal to the square root of C squared. So that gives the square root of 41 equal to C, and that means C is going to equal, what's the square root of 41? Square root of 41 is 6.403 to 3 decimal places. So we can check that this answer is reasonable to the context of the question or the situation. Well, what do we know about the hypotenuse? We know it's going to be the longest side in the triangle. And given that there's not much difference between these two values, the hypotenuse isn't going to be much longer than the other two sides. So the hypotenuse's length, call it 6.5, 6.4. And that's just a bit longer than the other two sides. So that's a reasonable answer in this situation. Let's have a look at another example. Let's label what we know about the triangle first. We know that this is side length 6 and that's side length 5. So this is the hypotenuse because it's opposite the right angle triangle. So that's side C. And it doesn't matter how you label the other two sides. I've gone for B and A. Let's write out the equation and put in what we know. So A squared plus B squared equals C squared. So let's fill in what we know. 6 squared plus B squared. No, sorry, that's wrong. We've got 5 squared plus B squared is equal to 6 squared. Now, hang on a minute, we've got B squared on the wrong side. How do we deal with this? Well, if we subtract 5 squared from both sides, then we're left with B squared on one side on its own, which is what we want. So, we get B squared equals 6 squared minus 5 squared. Since we've subtracted 5 squared from both sides. So now if we square these values, we get B squared is equal to 36 minus 25. So b squared equals 11. Now again, we want to get rid of this squared. So we're left with the square root of b squared is equal to the square root of 11, which leaves us with b is equal to the square root of 11, so b equals 3.311. So is this answer reasonable in the context of the situation? Well, we know the hypotenuse is the longest side, which is 6, and indeed it's less than that. You can't always give it as a certain that an image of the triangle is actually going to be to scale, but looking at it as a rough estimate, 3.3 is less than 5, and this side looks considerably shorter than 5. So it appears to be correct in the context of the situation.